Hey, welcome back. So in the last video, we went for snappyHexMesh, and we are making a very fine kind of a mesh from our cylinder. And as you can see, there are problems usually associated with the edges. So normally during the edges is where snappyHexMesh kind of falters a bit. That is normal. It's a part of snappyHexMesh. And of course, there are a few workarounds around it. I'm just going to introduce you to some of them. Yeah, these are usually external utilities. Okay, where did I put this? Yeah, okay, so you go to this, and then you see for sharp edges, there's a user-created utility called snapEdge. It's not official, but it works well. So stuff like this can actually help you resolve the edges. The corners, they are usually more iffy. Excuse me. Yeah, the corners are usually more iffy. Therefore, you need this kind of thing that's going on. Otherwise, it's pretty much okay. We won't talk about that. I just want to introduce you to some of these concepts. And we noticed in our last video that our snappyHexMesh was taking almost 10 plus minutes. So we want to kind of reduce the time frame on that. So let's see what happens if we reduce the minimum refinement level to 0 and the maximum refinement level to 5. So it will refine the edges. It will refine a lot around the edges, so that it will. What was I gonna say? Yeah, so that it will refine to a level of 5 around the corners, but 0 everywhere else. So hopefully that saves us a lot of time. Okay, so I'm gonna save, and I'm gonna run snappyHexMesh again. So you see the iterations are running much quicker. So you see, if you don't refine the rest of the block, so to speak, all these things become much easier, done in less than 1 minute. So let's take a look at ParaView. I'll delete this old one. So let's apply. Okay, so what do we see here? Wireframe or surface with edges. So this is what happens when you don't refine as much. You see that the corners are very, very well refined, but towards the center, maybe, there is some discrepancy there. But you see the edges are captured very well, and we note that it's a lot faster. So look at the same thing. Yeah, the castellated mesh, it will show you what's going on, which blocks are being selected and which are not. So surface with edges, yeah, it's here, and this is how it looks after snapping. So probably you still want some level of refinement, so probably give it a level 1, for example. And let's see. So you will always want a balance between computation time and accuracy. So let's see what happens if you do a level 1 minimum. So I'm gonna take another 30-ish seconds. Okay, 41 seconds, 42 seconds. Let's see what happens. Okay, so again, it's slightly smoother. As you see, there's still some issue around there, so you do need some level of refinement. And why not we use level 3 then? So this is just playing around with the settings and see what happens as we alter the refinement levels and see how the model changes. I'll just wait for it for a while. Looks pretty okay. It's not lagging excessively. And we'll just let it continue for a while. So yeah, that's how we play with the refinement levels. So while we wait for this thing to finish, next thing we probably want to talk about is the snap controls. Now remember, refinement mainly deals with this thing called the castellated mesh, which kind of gives you this kind of a blocky approximation of the cylinder that we want. If you have to do the snap controls after snapping, it should ideally look more like a smooth cylinder. Unfortunately, in this case it does not, perhaps either because the mesh wasn't fine enough and it makes it very hard to do the snapping properly, or we could also consider if that's the problem of something wrong with the snap controls that is not ideal for this situation. So let's we can go through some of the snap controls after this thing is done. So yeah, there's nothing to handle cells with snap problems, so it should be more or less inside the snapping step of it. And of course, the more cells you have, the more accurate your snap is gonna be, or it's easier to get an accurate shape with your snap, of course. Look at the surface with edges. Yeah, you realize how it's good. Okay. See at the corners, it's a very if you put a refinement level of say 5, see the corners are very they are pretty okay as compared to if you don't refine them too much at all. So the corners are taken care of. It's just these center edges over here, boundaries just behind the corners that are so-called more problematic. Okay. Alright, I'm gonna fast forward. I'm not gonna wait. Now fast forward is done. So we see it's done at 230 seconds, which is just under 5 minutes. Alright, so I'm going to delete this. Let's check out the mesh quality. So 5 minutes is pretty okay still. You can go and do it, go get a coffee and then come back, see what the thing is like. Reasonable. Take a look at that, so smooth. See, so we don't need 40 minutes to get this kind of a good resolution, so to speak, with maybe a 5 minutes. That's all you need to get a smooth surface in this cylinder. Okay, so but pretty much throughout all of this you have very small mesh, so that I mean your accuracy, you'll have accurate calculations, but it'll take longer. Now it's up to you to play around with this mesh. So next thing we want to take a look at is probably something called snapControls. So I'm going to VI the snappyHexMeshDict. Yeah. Well, the thing is that you want to see how the snappyHexMeshControls, how will they actually affect the shape of the final output mesh. We want to have a rather not so good looking mesh in the first place. So we're gonna use a rather ugly looking mesh and see how this snap control actually affects it. It's easier to do it this way. So we know how the level 2 and 5 refinement already looks like. Let's take a look at this thing called snapControls. Over here, what I'm highlighting. So the first one is called nSmoothPatch, and it says that's the number of smoothing iterations before finding correspondence to the surface. So yeah, well, if we have it more, okay, if we have more iterations, generally speaking it will be better. So again, let's take a look at just the number 3 with a level 2 and 5 surface refinement. We do a snappy hex mesh, it should take about 40-ish seconds. So want us to just compare. Okay, fast forward again. Alright, fast forwarded, it's done in about a minute. Which is about the same time. Not too bad. Okay. Just a reminder of how bad this surface looks like. Yep. Snappy pipe foam. So you see, it has all these rubbish looking edges to it. Okay, but the advantage is that it comes up really quickly, so that's a good thing. It's just all these edges that look really yucky. So maybe we go and increase the number of iterations for the snap. Hopefully it will make the surface smoother. So I'm going to change nSmoothPatch from 3 to 5. Let's see what happens. So again, it's refining. I'm going to fast forward again. Okay, so this thing has been done in about just over a minute. So that's finished meshing. Let's see how this is affected. It should be slightly better than what we had before. Okay, well, looks like this thing doesn't really help very much at all. Over here, it still has this rather ugly looking thing, so it seems that refinement is the better option. Next thing we can try, instead of getting nSmoothPatch to 5, maybe we can look at the tolerance then. It says the relative distance for the points to be attracted by a surface feature point or edge. True distance is this factor times the local or maximum edge length. Let's put this to 5 then. And let's see snappy hex mesh. What does it do? Fast forward again, and this will be probably the last thing we discussed before end this video. So now this is 58.31 seconds. So go to ParaView and just see how it changes the mesh and see whether it solves our problem. Okay, so this doesn't really help at all. We still have this issue down here. Okay. Perhaps the next question is to look at the other snap controls here, end solve iteration and relax iteration. So that's what we want to look at in the next videos. So thanks for watching. I'll see you guys next time.